So now that we know how to count significant digits, I'm going to show y'all how to use that in calculations. So this is how you will know how to round off your answer. And from now on, we're going to be grading based on that. So for example, whenever you're adding or subtracting, so specifically when you're adding or subtracting. So let's do this example here, 12.52 plus 349.0 plus 8.24. When you're adding those and you say, Miss Beckham, how many do I round off to in my answer here? Let's go ahead and get the answer here. So 5 plus 2 is 7, 9 plus 8 is 17, 18, 19. I'm going to add that there. 4, 5, 6. I hope I'm not wrong on this. That'd be embarrassing. Okay, so how many do we round off to? Well, we have to round off to what the least precise measurement is. So basically, you are going to count for each one how many numbers are after the decimal place. If you look here, 349.0 only has one decimal place, and both of these have two. But because the limiting factor is this one, we have to round off to one decimal place. So that will become 369.8. Okay, so let's look at this example. 74.626 minus 28.34. So we get this number here, but because the 28.34 only has two decimal places, whereas the 74 has three, we have to round off to 2 because that's our limiting factor. So 46.286, we round up to 46.29 for our final answer there. So let me know if that makes sense for y'all. Ask me if you have any questions. So that's whenever you're adding and subtracting. Whenever you're multiplying, you will keep however many the least amount of significant figures there are. So for 7.55 times 0.34, the answer to that, whenever you multiply it, is 2.567, okay? And then our next step is to count the significant digits. So 0.34 has 2 significant digits, and 7.55 has 3. So because 2 is our limiting factor, we have to round off to 2 significant digits, which would be 2.6. So notice that for adding and subtracting, you're looking at how many are past a decimal place. For multiplying and dividing, you're just looking at overall how many significant figures there are and rounding off to that. So it doesn't matter about how many decimal places there are. It matters overall how many significant figures are there. So it's a little bit different between adding and subtracting and multiplying and dividing. So for 2.10 times 0.70, 0.70 has 2 significant digits because it has this 0 counts because it's a trailing 0 that has a decimal place. And this first 0 doesn't count because it's a leading 0. So this one has 2 decimal places and this one has 3. So we're going to round off our final answer to 2 decimal places because that's the limiting factor. 2.4525 divided by 8.4. 8.4 is our limiting factor. It's got only 2 significant digits, so we're going to round off to 2. 0.365 times 0.0200. 0.0200 has 3 significant digits, right? Because you don't count the zeros before the decimal if they're leading zeros. And then 0.365 also happens to have 3. You don't count the 0 because it's a leading 0, so there's 3 there. So we're going to round off our answer to 3 significant digits. They both have the same number. We just round off to that, which is 3. So let me know if you have any questions on that. So whenever you're doing multiplication and division or adding and subtracting in your calculations, you have to round off to the correct number of significant figures based on these 2 slides. And the previous slides just tell you how to count significant figures. Okay, so for scientific notation, hopefully this is a review for you guys, but if not, no big deal. For scientific notation, it's a way for us to simplify really large or really small numbers. So if we were to put this into scientific notation, you would assume that there's an imaginary or an invisible little decimal place right here. And to move it to scientific notation, you move over until you get to a digit that's between 1 and 10. So we go over 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then we have 3.67. So we're going to have 3.67 times 10 to the positive 9th. There's 9 digits after it. For this one, we're going to go to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 5.3 times 10 to the negative 11th. So we put a negative here because it's originated as a really small number. So whenever it's small, you put a negative because it's going to be going backwards. Whenever it's a big number or past 10, you're going to make it positive because you're going to have to move past to the right. These other slides here, you guys can practice with these and let me know if you have any questions on it. So for example, if you have the number, 0.002, and you want to move that to scientific notation, you're going to go 1, 2, 3. It's going to be 2 times 10 to the negative third because it started off as a small number, or smaller than 10 if you want to view it that way. So if you're given numbers in scientific notation going backwards, you just kind of do the opposite thing. So if you got this number here, we need to move to the right 3 digits. So you've got 1, 2, 3. So we've got to add a 0 right there, 5,230. For this one, we've got a negative sign, which means we've got to move to the left to get back to where we were. So we're going to go 1, 2, 3, 4. So we need a 0 here, a 0 here, and a 0 here. It's going to be 0.000438, and you can double check, and then this would go away whenever we're changing it back. So you can double check, because sometimes I feel like it's hard for me to count. So it's 1, 2, 3, 4. So we know we did it right. So let me know if you guys have any questions on those. You can try them on your own. That's all that I have for you guys today.